Welcome to the notes on simplifying rational expressions. First thing we should probably know is what is a rational expression? Well, these are all examples of rational expressions. They're basically a fraction that's a polynomial. So we've got monomial here. We've got a monomial over a trinomial, trinomial over binomial. These are all examples of rational expressions. Today, we're going to simplify those. Quick thing to remember right here. All right, if we have a fraction with a negative sign in front, that means that you either bring the negative to the top or the bottom, not both, because a negative would be a positive. And you're going to see an example like that in a little bit here. Other thing to remember, all right, when we list out our factors and we've got variables and constant terms, we want to list those variables first. So in this problem right here, we want to rewrite that so that the x is first. So we can do that by just switching the order as long as the signs are the same. This is a positive x, and this is a positive 2. So it's x plus 2, and then that is over our original x plus 2. Now, if you notice, this is the same thing top and bottom. This will actually cancel out, so this will equal 1, because x plus 2 over x plus 2, it's the same thing, top, bottom, that'll equal 1. All right, you'll see me put a line through it a lot of times, cancels itself out, it's a factor of 1. All right, now this other one right here, this is the example a lot of people struggle with. Okay, so the first thing we want to do is, obviously, let's switch that order, all right? We want that coefficient in front. So when I do that, I'm going to get negative x, all right, and plus 2. And then this is going to be over, all right, this is going to be over x minus 2. Now notice they're not the same. Here's the trick to these types of problems, all right? They got the x and they each have an x, a 2, and a 2, but the terms are switched. So right here, we need to factor out the negative 1. So right here, I'm going to factor out a negative 1 out of that. Now when I do that, all right, I'm going to rewrite that. So taking out the negative 1, I'm going to be left with, it changes the sign. That becomes a plus positive x, and this positive becomes a negative 2. And then that's over x minus 2. So factoring out negative 1 is really important. You can see that this will actually cancel out. So our final answer, that would be an example where that would simplify to negative 1. So now that we know what some rational expressions are, they're going to ask you to list some equivalent forms. Equivalent forms mean equal. Well, here's that negative sign. Here's all we're going to have to do. We're going to have to distribute it to top and bottom. So here's what you're going to do. This would be the same as saying negative. Now you need parentheses because you're distributing to every term on top. Right? When I move it to the top, and then that's over, the bottom doesn't change. Now, if I wanted to, I could also rewrite that as, I'm going to kind of slide down here a little bit. I'll change colors. I could also do it as 5x minus 1 over negative x plus 9. That would be another equivalent form, because remember, you can move the negative to top or bottom. Another way to rewrite that now is if we distribute the negatives. So on this first one, I'm going to distribute that through. So I'm going to have minus 5x plus 1 over x plus 9. That'd be another equivalent form. And over here, I would have the 5x minus 1 over negative x minus 9. All these are equivalent forms. Just understand when you have that negative sign in front, how you have to distribute it to either top or bottom. Now we know that background. Let's finally get to some examples. Simplifying a rational expression in lowest terms. There it is. All we're going to do is we're going to completely factor the numerator and the denominator, all right, which we already know how to do. And then finally, we're going to divide out factors common, all right? Basically, they cancel out. It's the exact same thing, top, bottom. Let's get to some examples right now, all right? Top, we've got 2x squared. That doesn't simplify, all right? So I'm just going to have my 2x squared. On the bottom, this right here, we can factor. We can take out a GCF, step 1 of factoring. Well, when I do that, they each have a 2. I can factor out a 2 and an x squared. When I factor out that 2x squared, I'm left with a 5x and minus 1. All right, I factor out 2x squared. The other factor is minus 1. Now I can cancel the 2x squared. Before, I could not cancel these out because this minus 2x squared was part of the minus 10x cubed. But now that we're just multiplying, I've got them isolated, I can cancel these out. So on top, it doesn't become a 0. On top, I have a 1 up there. All right, and then on bottom, I have the 5x minus 1, and that is your final answer. So just factor and then see what can cancel out. Let's do some more examples so you can see each type of problem you're going to see. All right, here we go. Trinomials. All right, on top. All right, on top. All right, leading coefficient 9. I have to use tic-tac-toe. So to factor out that trinomial, here we go. Remember how this works. Done this before. Put our 9x squared We put our 4, we multiply. 9x squared times 4 is 36x squared. Now I need a factor of that adds up to positive 13x. So that would be 9x and 4x. Then what factors are 9? Well, it's got to be 9x and 1x. 9x times 1 is 9x, 1x times 4. There you go. So these are my answers right here. So when I rewrite that equation, all right, that's going to be, I'm going to break that down into 9x plus 4 times x plus 1. Then that's going to be over. Now on the bottom, when I take a look at this trinomial, now it does just have an x squared, so I can just do double parentheses. I know x times x, what multiplies to 6, that adds up to positive 7x. Well, that's going to be plus 6 plus 1. Now we look to see if we have any common factors. This will cancel out. So then our final answer is right here. That's just going to be 9x plus 4 over x plus 6. All right, this right here, what's left? Another example. All right, we've got 18 minus 2x squared. First thing I'm going to do on top, I'm going to rewrite that. So I'm going to put the minus 2x squared first, and then the plus 18. And then that's going to be over x squared minus 2x minus 3. Well, so this one right here, all right, on top, I'm going to factor out, we want to factor out that negative. So when I do that, all right, I'm going to take out a negative 2. I'll be left with an x squared plus, minus 9. Again, take away the factor on negative, it changes that positive 18 to a negative. All right, and then on bottom, all right, what happens to this right here? Well, we know it's going to be x and x. And then what multiplies to negative 3 adds up to negative 2. Well, it's minus 3. All right, and that's plus 1. But this right here, this is a different of perfect squares. You're not done, all right, because we don't have anything that can cancel out, so we can break that down further. So when I do that, this is going to equal negative 2 times, well, remember, difference of perfect square, x plus 3, x minus 3, all over x minus 3, x plus 1. So then you can see that the minus 3's will cancel out. Our final answer then is, we'll do it right here, is negative 2 x plus 3 over x plus 1. So there's your final answer. 2 more problems to take a look at. This right here, difference of perfect cubes. You're going to use SOAP. So if you guys remember how that works, all right, I'll factor it right below here. We're going to take, what's the cube root of x? What times what is x cubed? It's x. Signs stay the same. 2 times 2 times 2 is 8. And then I just follow that pattern of x squared. Take the first term, square it by itself. Opposite sign. All right, then I take these two, the x times the 2 and times them together. That's going to be 2x. And then my last term is always positive when I square the second term, which is 4. So there's that factor right there. And then on bottom, I'm going to switch the order to make that an x plus 2. Okay, now when I factor that out, this right here will cancel out, and then here's my final answer: x squared minus 2x plus 4. All right, there you go. And then one more. Let's do one with grouping. On top, I'll factor out the 2, so that's going to become a 2. All right, and then I'll be left with x squared plus 1. All right, then on bottom, grouping. Remember, we take the first 2 and the second 2. All right, so when I do that, all right, I'm going to take out the x squared. I'll be left with x minus 5 in the first set of parentheses. And then I've already got an x minus 5 here, so I just put plus 1 times x minus 5. And then I'll rewrite that. Remember, we take the common denominator out. So I take out my x minus 5, and then I take out what's left. I'm left with x squared plus 1. Well, now you can see that doesn't break down. That's not a difference of perfect squares. These will cancel out, so I'll be left with 2 over x minus 5. So there you have it. That is how you simplify rational expressions. You've seen each type of example that you will see in the homework.